Hey everybody, this is Larry. This is me trying to do the contest. If I could click on contest. The last contest, weekly contest 454. Hit the like button, subscribe button, join me in Discord. Let me know what you think about this contest, these prompts, everything in between. This is the live recording for each individual explanation. Definitely check out those videos. Yeah, that's what I have. Let's go virtual contest. Let's Let's go. Do. I always forget where the buttons are now these days. All right, let's go. I always also forget that to reset the thing. All right. Am I recording? Yep. Okay. Yeah. Combine all words. Camel case. Okay. I mean, it doesn't seem that hard. Just very easy to mess up. Okay. They don't define what a word is though, which is a little bit weird. But I think there is a I thought there was a camel case library function, standard function, but I'm wrong on that one maybe. Okay, so word to lower first letter of all words is capitalized. So we lower it, and then the first word, right? So something like that, and then now we want the first word to be lower, right? So this is actually inside, and then we just return something like that. Problem is that they don't tell you whether this is like accurate-ish, like if given these expectations, like should that be, I don't know. It looks okay, but it's very easy to make a silly mistake, so I wouldn't be surprised like that. Like, how can I tell that I missed 2 characters because looking at these outputs, you know? I mean, that, oh, actually, I don't know. That's really weird. Is there, did I change? Oh, I missed the 100 max. Okay, that's fair. Yeah, I just didn't see it, to be honest. But like, truncate the result. So that actually includes this, I think. I wish there's a way to kind of I mean, I click on use this, but it didn't seem to use it. Maybe it did, but is that the see, like this should be automated, right? So I guess that, so I did mess up on the example, but it's just hard to count, and I honestly didn't even see it, so I mean it's fine. So I guess I have to do like a manual comparison, because I don't want to get another wrong answer. Okay, so that looks good. So let's hopefully better results this time. Hi. Man, today I am not good. When the Yeezy is sad, then it's gonna be sad. String out of bound. Why? Oh, because of this thing? Why? Yeah, I thought split does that, but okay, fine. Oh, Actually, I mean, I should have been a little bit better anyway, because it tells me to remove all characters that are not an English character anyway. But so maybe that's another case anyway, right? But only in so I don't know. All right, let's go again. Really silly mistakes. I don't know what to tell you. This is a very silly problem. But in write a test case, isn't that oh, I see. Is it just hashtag? What is the expected answer? It doesn't even tell me. I guess YOLO. I mean, I only got 3 wrong answers, so I guess at this point I am already forever behind with 3 wrong answers on Q1. But it's okay. You know, this is what happens when you do things at 3 a.m. Maybe I should have gone to bed and did tomorrow. I got it. Also, honestly, I kind of tilted a little bit in the sense that I probably could have slowed down a little bit. All right, let's just figure out this one. Okay, you have IJK, N is 10 to the 5th, so we have to be smart. IJK, I is equal to, and so then we have to loop on J and then times 2 on the thing. Okay. Oops, that's not right. Mod. All right, and then now it's just the number of things that are on the left. That's times 2, and yeah. So for J in range of N, so we want the okay. So right is equal to the connections dot counter of nums. Okay, so then now we remove right of num sub j. Though it doesn't matter because you can trigger itself. But actually, I guess you can with zeros, and you can have zeros for sure. That's probably. Oh, I was gonna say that's a trick case, so maybe not. Yeah. Anyway, right. So here, count is equal to num sub j times 2 times value num sub j times 2, and then count and then I think that should be good actually. 1 1 2. All right, YOLO submit. Okay, that was easier than Q1 for me, apparently. Okay, maximum product of first last element of a subsequent. First and last element of a subsequent. What does that mean? We turn the maximum product of the first and the last elements of subsequence of nums of size m. Okay, m is equal to 3. Oh, but there's subsequence though, right? So it's a little bit weird. Maximum product. It's a very weird one. I feel like there's a very easy solution. I mean, I don't know that I know it. I'm just saying that there should be an easy one. Right. Yeah. Okay. So then. So then now, you're just sliding windows, right? So num sub I minus m is getting added. Well, 1 is 0, so then it would add itself. So that's fine. So then here. So then here we want to add this to the sorted list. And then now num sub I, we either times it by the maximum or the minimum, right? Did I get that wrong? Maximum minimum, right? Okay. I mean, maybe I'm off by one. I minus m. Oh, I see. Okay, that's what. Okay, well, we fixed this one, but this one not so much. Why? Okay, so at 6, it can take. That's already wrong. No, it's at 1. Why is 6 in there? Oh, because I go on. Okay, that is just me being dumb. But that should give me a better answer, though, right? And not a worse answer, so I don't know. We'll see. 80. Okay, actually, that's fine. I guess I was getting a bigger answer. YOLO submit. I mean, n log n should be fine, right? Yeah. All right. I mean, we're making up a little bit for the fact that we have 3 wrong answers on Q1. In fact, that was my slowest problem so far. But I mean, Q4 is hard, so we'll probably slow down, but that's fine. Find weighted medium node in a tree sounds annoying. Okay, you're given. I mean, that always sounds like some sort of weird heap type thing. We'll see. All right, you're given an integer n in an undirected weighted tree. Node rooted at 0 and nodes from 0. Okay, you have a tree. Okay, that's what this. Weighted median is the first node x on the path from u to v, such that the sum of the edge weights from u to v is greater than you go to half of the total half weight from u. Okay, that's key 1 point. Okay, so maybe that's not a heap. I didn't, but. Okay, so I have a tree. I mean, I think I get it. I feel like it's binary search, right? But for each query, n log n, is that too slow? But we have like most of this done before, so it's kind of weird. Like it's in the LCA and like the weight. I mean, it's just setup, right? Like, I don't think there's anything too difficult. You get the LCA. Can I set it up easily? I mean, it's annoying, but I don't know. You just binary search up, binary lifting up to the LCA, right? Or even, okay, actually no. Even the LCA will tell you whether it's on the left side or the right side, and you just binary search on that. So that's gonna be n log n or something. So conceptually, this isn't that hard. but it is just very annoying. And I am a little bit lazy today, so I am gonna because we did this like 2 weeks ago, maybe 3 weeks ago now. I don't remember anymore. But I don't know what did I just click on? But we did this like very relatively recently, right? The LCA things. Maybe this one, I don't know. It was a hard, but just being lazy. Yeah, this is it. Or this this is the one click. It is. Yeah. Okay, so we get the distance. Maybe. I mean, we have to maybe make some modifications, but this is like a lot of the code, right? And not gonna go over that now. You can watch that another time. But what is M again? M is for the binary lifting for. Okay, so this is the ancestor code, LCA, the distance. This is still true. We just have to set up distances correctly. So this is D. Right, okay. So we have to set something up. This is actually, I mean, that's what I need from this, I think. Maybe I need this. I don't know. Okay. So yeah, so this is a really weird problem for sure. Okay, so yeah, so this is all good as long as we're able to get D, but D is not, where's my go function? So it's not D plus 1, it is going to be W for some edge, and then this is going to be W. Yeah, I think that's fine. I think everything else, that's all I need, which is kind of crazy, right? Like how much code we can copy and paste once we know it. And I even show you how I copy and paste it this time. But yeah, and then now we have to set up the edge list. Oh, I guess we actually have that here, except for we add in the rate. So then we add in the rate. Usually, I honestly a lot of these things I do try to type it out and try to do it from memory, but today I'm just a little bit lazy. And also, this is just lazy. This wasn't that long ago that I'm like, okay, maybe I should be fresh. This is like literally like I could do it because it's too fresh almost, because we did it twice within a month, so that's just lazy. But okay, so then now for UV inquiries, answer right. So I'm not gonna return the answer yet, right? But print distance from UV just to make sure that this is what we think. For example, this should return 7, 6. What does it say? Total 0 to 1 is 2. So why does it have 6? Is not right actually. Do I always root at 0? Yep. Oh, I know why. Because I did it, because I assume all the edges are 1 based on that one. I remember seeing it when I was just writing it. Okay, so now this is right. That's why we audited, right? Before we do anything more. 7, 7, 2, 4, 6, 11, 7. So that means that already we did like a good amount of code, right? Which is ridiculous. I don't know how long I've spent here so far, but okay. And then now we do the LCA, right? So for UV, let's get the LCA of UV. Oops. So L is equal to LCA, and then now the distance from U to L. Okay, wait. Well, okay. So D total is equal to distance of UV, say, and then now DL is equal to this. And then basically the idea is and there's another one where I do the binary search, so maybe I have to do that more correctly. Okay, so So okay, so what am I doing, right? So it's just converting it into a place in which we can do this binary search here with the distance. Okay, so then that means that what's on the left side, right? So if d of L is less than or equal to d total over 2, I'm trying to think how to do the 0.5 math. Or like if it's equal to, do you round down? I guess so. Round down closer to the 0. Anyway, in this case, it'll be on the U, on the path from U to L. L's on the path from L to V, technically. I think maybe that's right, maybe that's not. Because I think they use different terminology on it. No, it's fine. No, this is right. It's greater than or equal to half. So if this is less than, so maybe do, I don't know. And this is roughly right now. So that means that, okay, now we do a binary search. Now we want to say, wait, is this right? If half of it is greater than or that means that, no, this is wrong. That means that this is the other way around. If this is greater than or equal to, then, because then if it's, yeah, that means that half of it is, okay, yeah. Okay, so that's right. Then now we want to search for it in, I don't know, pen search from U to L to d total divided by 2, maybe. Again, I don't know. It's very possible that I have wrong answers, but that's fine. Let's write that first. Okay, so start ancestor target, right? And then now it's just binary lifting of I in range of m minus 1 minus 1 minus 1. If not, no. I'm looking at this code because you're wondering. For LCA, that's not quite right. What we want is actually, okay, so we don't want to go past ancestor. So how do I do it? So then parent sub I of node. So if this is the ancestor of this, I think so. I forget which one. Node and potential ancestor, I think, yeah. If this is, but the other way around, we want, if the new node is the ancestor, then we just continue because we've gone too far. Maybe. I think that's right though. Unless they're the same, maybe. We'll check. Because it will be in itself. Yep, okay, fine. If ancestor is not equal to parents of I of node, and this, then we skip. Otherwise, we considering hopping. Do we hop up? And we hop up if the distance to the distance to okay, it may be called considered is equal to parents of I of node. If the distances to the node we're considering, if I guess we could actually I guess we could use this formula, but then this is another LCA query, which is kind of expensive. We should be able to roll that in, which is if the distance, because this is always the parent of node, so that means that if the distance here, it's going to be smaller than the distances from node, if this distance is smaller than or equal to target, then we actually want to take the step. So then we say something like node is equal to consider, right? Yes, but then we have to update target, because then now, yeah, okay, so then delta is equal to this thing, and we already moved, so then target subtract delta, and then node is equal to consider, and then when we just return a node, right? Maybe? I don't know if this is quite right, but just return -1 for now. We have to do the logic through it. Is this right? Maybe not. Well, I mean, it's definitely not, but I want to know if it's like a rounding error type thing or whatever. But okay, so we have two edges. We have, let me draw it out. Okay, so 0, 1, 7. Okay, so there's actually just like one linked list, but okay, so from 0 to 1. Oh, sorry, from 1 to 0 is the first one. So the answer is 0. Why is that 0? From 1 to 0. Oh, it's greater than or equal to half. Okay. So actually, I think maybe I defaulted on the other way, on the tiebreaker, because I misunderstood it. Let me double check. Okay. Maybe, I don't know if I need it. Oh, well, I need this for the not skipping. Because if it's the skipping, yeah, okay. So because we do want to consider ancestor. I guess that's why. But, okay, do we hop up? And the answer is no for some reason. So then, I mean, this is just going to be this is very awkward, right? Because maybe that's fine actually. Okay, so then this should be true. Let me write something. So we don't print that anywhere, so that's good in that it is consistently wrong. So then, okay, why is this wrong? So node is 1, this is 0, this should be 7 minus 0 is less than or equal to target, so we do hop up. Oh no, target is 4, right? But we're type working in a weird way because we want it to be, because we want to hop up if it's, oh, okay. So maybe in this case, we want it to be strictly less than target. And then here we want the parents of this one, because then the next, because then now we're going strictly under. So then the next one will be good. Maybe, I don't know. I mean, this confirms it for this one, confirms it for this one. These, I don't know why. I mean, it may be, okay, so 1, 2, they're in different branches. So, and we're searching for 7, so it's going to be on the other side. So, okay. So yeah, so that we won't get the answer for that one. And also the same way, we won't get an answer. Or we have, that's the part that we have here. That's what I mean. Right, so that's why. Okay, so maybe we're okay now a little bit, but let's let's kind of see. Okay, what does L to V mean, right? Okay, L to V, because we want to reuse. Oops, we want to reuse this, but how can we represent this as V to L instead, right? Especially on the tiebreaker. I think the tiebreaker is the tricky part because. Okay, so. I don't know, what if I just do this? Does that work? Nope. Why doesn't that work though? Because tiebreaker, well, the tiebreaker goes the other way is probably why, but I don't know if it's that simple though, to be honest. Because this seems very sketch. that everything is just 0. Because even from 0 to 1, half, no, I guess that's fair. I guess if it always goes to the parent, then it's always going to be 0. 1 and 2. Then 3 is going to be 0. So yeah, this one. Oh no, 3. So then 1 here. Okay. So I knew that it wasn't just that, but I was hoping that maybe it would be more illustrative. Here 1 to 2. 1 to 2, there's 7. So 3.5. So you want to go. It rounds up to 2. So maybe I have to do. Okay, so maybe I return the node here, and that's fine. But then now here we want the parent. I mean, what I want to do is something like, okay, here we set the parent, here we set the child. But I don't know that that's easy to do with the way that we have it set up. Okay, maybe I just, I was trying to avoid it, but maybe we can just rewrite this in a lazy way with a search 2 for now. It's a little bit tricky to kind of, I don't know. Okay, right, so then now we have target, but then now we can rephrase the question because we don't need the parent. Maybe we just need the node. And then that's good, maybe. Nope, still no bueno. Why? Five, let's go to 3. Oh, I don't call search 2, that's why. I mean, it's right. I am going to YOLO because why not? I wouldn't be surprised if I have some off by 1 hours, right? Because it's just so easy to have off by 1 hours. But you know, like this one, it seems like we have 0 to 1 with edge of 1, and this is a very basic one. So I'm surprised I didn't catch on the whatever. But from 0 to 1, so it should be on this path. Yeah. Yeah, so okay, so it should be on this path. Oh, I see. It's because of the. I want to say maybe it's because of the division. That's why. Just want to double check. Actually, it doesn't. Because of this. Oh, because of this. Oh, because because of this division thing. Okay, that's a sloppy mistake actually. I was thinking about it, and actually I should times 2 on the other side. I'm just being lazy. Okay, let's just fix it then because we still got wrong answer anyway. Okay, I mean, like I said, there are a lot of because maybe I could have done it this way. I don't know. Maybe that's what I should have done. Yeah. All right, let's see. Actually, I'm really bad at this because I probably don't need to do this. I just need to times everything by 2, right? Yeah, actually, that's what I should have done. I should put all the weights times it by 2, and then now when I divide it by 2, it's a whole number, and then I don't have to have okay. I mean, it may still be wrong, but at least now I never have to think about this. Okay, so 0 to 1. Okay, so yeah, this is the midpoint error that I'm running into. We go from, oh wait, no, not even. This is just a cell to itself. So, okay. Because I automatically choose the parent here, but it is to query, so okay, fine. I don't know if this is fine, but I mean, this obviously would fix it, but I don't know if that's this, if I'm running into issues with a more general case. But I am lazy and tired, and the problem itself is not hard. A lot of edge cases with the tie breaking and everything, definitely very tricky. Though now maybe I have to re-examine how I do equal signs, because before I wasn't really thinking about it. No, we want to get the number that's smaller so that yeah, so that goes to the next number if it's equal to. I don't think that I handled that. No, this is, I know this one is right, but the other one I'm not super confident about. Let's draw this tree. 0, 1, 1, 2, 1, 3, 0, 4, and we're messing up on the 0, 3. Okay, so 2 nodes up. There's gonna be 1 and 1. So the answer should be 3. But oh no, yeah, oh no, my answer is 3, but the answer is 1. Why is that? 0, 3 LCA. Yeah, LCA should be so the LCA is 0, so it's going to be on this path. We search from 3 to 0. Alright, let's just make sure that and for answer 1, oh, it doesn't print. That is actually maybe not great. 0 to 3, yeah, okay. Distance. So the 3 distance is 4. Did I misread that one? Oh yeah, no. I doubled the distance, so it's 4. So then now we're looking for 2. Also, why do I? Oh no. Yeah, okay. So we're looking for 2 from 0 to 3, though, right? This is definitely bigger. So why is it not printing this? Did I miss something? DL. So this is definitely wrong. U to L. LCA of U to V. I guess we just put LCA. 0 and 3 should be 0. So yes. So LCA is 3. So the distance from U to L is 0. Oh, this is the distance from 0 to 0, not... Okay. So that means that it should be on the other path. Okay, no, and that's correct, actually. I misunderstood how I phrased it. 0 to... Okay, so that means that then now we go from 3 to 0 with a distance of 2. Right? Yeah, that's what I wanted, I think, anyway. Oh, we. Okay, 3 to 0. So search 2 is wrong. Why is it wrong? Because it is exactly equal. Okay, what would I do in the exactly equal case? Okay, so it looks at, do we hop up? Okay, it goes, okay, we don't go all the way, we go to we do hop if it's equal, I think. Okay, yeah, because it's of the equal. Okay, fine. Okay, is it good enough? I don't know. We already got like 3 wrong answers on this one, so why not get a 4th? Why is this loading so long? Okay, I mean, I think the core idea is not hard, but clearly, as you saw, I was very worried going in on the off by ones, and clearly justifiable, but I was just too lazy. I mean, honestly, it is 3:20 a.m. here, so it's kind of like like that's my excuse. Whether But yeah, I mean, I don't think it's that interesting. I think that's my biggest problem with this poem. But I still took 27 minutes, even though I got most of the answers in like very quickly. But a lot of it is just working this out, and yeah, and I took. I mean, I'm a little bit slow, but like I guess 8 of those minutes were just like on silly cases. So how long did I take again? 27. So maybe 20 minutes. It would have been okay. I don't know. I think some part of it is that I'm just tired, want to get it over with. But overall, like the problem, the idea, I don't think there's anything too tricky about it. If you have the foundations down, right? Like I'm not saying this is easy, but for me, it should not have been tricky. And I knew, well, I mean, in terms of algorithmically, there's some stuff with, yeah. I mean, I think it comes out on how on practice, right? Because because if I was more practiced and more experienced, or more recently experienced, if you will, this times 2 thing, like I really should have been able to do immediately. Like this thing, yeah, like that is a second nature, and it's something that I've done like thousands of times, but didn't do it on this problem, and it cost me. I want to say 2 wrong answers at the very least. Yeah, and if I thought of it that way, then maybe I could have gotten these a little bit more precise earlier on. But I think I was just lazy and tired, because this one I probably could have fixed. I forget the other one. I think it's just a parent node or something. Actually, let's double check. No, not that one. What was this one sensor? No, this one was the off by the equal sign. And I guess the other 2 were actually. Well, one of them is this thing, which was the times 2 thing. So that should have been avoidable. This one maybe as well. Yeah, I mean maybe not directly, but oh no, this one I just thought maybe I could get that the parents or was rounding up the wrong way. But that was just me lazy, I think. No, maybe not. I think I fixed this. Anyway, it doesn't really, I mean, I'll go over it in the video, but I think I should have been able to do this without 3 wrong answers, but you know, it is just sloppy. I don't know. I usually kind of, it makes me sad looking at these leaderboard just because I usually spend this time, if some of you over the time know, like just to shout out to people, but these are all cheaters, right? So I mean, maybe not all. I don't know. 22 minutes. I don't know if that's possible in real time. I mean, I came close. I mean, if you kind of, or like a perfect version of Larry could have gotten in 22 minutes, right? Like, but at this point, no one gets a benefit of doubt unless I recognize their name or something, right? But like, you know, like if you want to say that a perfect version of Larry could get like a minute in Q1, like which is doable, not today apparently, then like, you know, Q2 you saw it in 2 minutes, Q3 was quick, Q4 should have been quicker because I had a lot of the code pre-win. So maybe if you even like, you know, even if you just take away the 3 wrong answers and let's say I got it correctly in the first submit because I didn't make that silly mistake, this would have been like 30 minutes minus like, I don't know, like 26 minutes or so. So like, you know, like maybe a little bit, and that's like a realistic perfect version, right? Like maybe I could have gotten a little bit luckier and better. Maybe I could have done it, but I don't know. And this is just me like as a sanity check. I'm not saying that, you know, that's likely or even very commonly, right? Like it's not likely, it's not, you know, maybe not even impossible, but just like an upper bound of what I would say, like given what happened, you know. But yeah, I would like to give people credit or whatever, but it's just at this point it is silly. Anyway, that is all I have for this one though. This contest. I think I'm trying to do a quick post-mortem or retro on these days, so let's do one. Q1, I mean, just a lot of silly. I just didn't read this part. Well, I mean that's definitely that's one wrong answer. The other is just that I didn't handle the 0 length things. Actually, I honestly thought Split handled it in a way. I'm not gonna lie. I mean, though, even if we did remove it, this would have failed anyway, or this would have been failed anyway. I should have considered it, but I think I just saw that it was easy, and I just didn't really think about it. I underestimated it, that's all. But I also thought that honestly, if I had double Like I thought it doesn't give me empty tokens, but maybe I'm thinking of another language, or maybe I'm thinking of regex or something. I don't know, but that's a little bit unfortunate. I haven't done it in a while, and also I didn't expect. I think some part of it is that they don't tell you what a word is either. So I mean, like there's a natural definition of word, but if you're gonna go with a natural definition of word, then you also don't have weird double spaces on things, right? So you have to actually define your words. I don't get why they don't do it. I don't know. Some of it, I mean, I complained about it before I submit even, right? So, because if you want to be precise, you should be precise. Because if you want to define, like if you want to have gotchas on impreciseness, there should not be any imposition in interpretation, right? So I think that's why this is kind of a, I don't know. If you ask me, I think this is a poorly written problem for that reason. I mean, I don't know. Like the concept is fine. It's an easy problem, so you don't really expect that much anyway. But I think they kind of did this way. I don't know what's up with this one. I mean, it seems pretty straightforward, as you can see. I mean, it did in 2 minutes after all, faster than Q1. Yeah, pretty straightforward. I mean, we'll talk. And just in case you're wondering, this is meant to be a retro, right? You want to, if you want problem explanations, we have a video for each of these. So Q3, yeah, same thing. I think subsequence is interesting. I guess like phrase wise, I think is interesting possibly, but I don't think there's anything arithmetically interesting. I think you just have to make one observation, and I don't even think that's a difficult observation. And then you write it out. I mean, I think I was just off by one. Well, I had a silly thing where I don't have an if statement, and Python being Python, negative index actually returned some stuff, so it was kind of confusing. And then of course I just needed to add this, but that was trivial to do. So yeah, pretty straightforward. And this one, I mean, I kind of talk about it a lot. Just off by one and being lazy. I probably could have tested it a little bit better for the wrong answers, but I don't know. Yeah, that is all I have for this one. That's all I have. Thanks for watching. And I just didn't think about the exactly equal the middle case, which is honestly that is on me more than the problem, for sure. Because if you think about it, that is literally the only edge case you have to consider, for the most part. Like, do you handle that correctly? If you do, then everything is easy, right? So I don't know. But yeah, that is all I have for this one. Let me know what you think. Thanks for watching, and yeah. Stay good, stay healthy to good mental health. I'll see y'all later and take care. Bye bye.